2.4, real zeros of polynomial functions. Now, did y'all have this example, the polynomial long division, in your notes? Okay, so you've seen this then. Beautiful. Well, I'm not sure.
I had to add in parentheses for like the one with the X's so that I could see that it's like not just like minus this plus this, it's minus this minus this.
I'm not going to do an example of it right now, but I might do another example for you, because sometimes just the more you see it, because there's stuff later that it does get used for. It's not just like not useful, but anyways. All right, we're going to start with synthetic division.
I forgot how to.
Because that's easy. So 2x to the fourth minus 5x cubed plus 7x squared minus 3x plus 1 divided by x minus 3. So whatever this sign is here, the opposite sign is going in the box. So we draw a little box and we put that number in it. Then we copy down all the numbers in order. If a term is missing, remember we have to put a 0 or your answer will end up being wrong. That's the most common mistake with synthetic division. So this is going to be 2, negative 5, 7, negative 3, and 1. So just something to note, this currently is an x to the fourth term, because when I get my answer, that's going to become an x cubed term. It's always going to decrease by 1 every time we divide. So we bring down the 2. So whatever the first number is always just gets brought down. Then we do 2 times 3 is 6, so 6 goes here. Then we add these together, so this ends up being positive 1. Times 3 is 3. Add them together, so that's 10. Times 3 is 30. Combine these, so that ends up being 27. Times 3 is 81. Add those together, so that's 82. So whatever number gets left here at the end, this is the remainder. So now this becomes an x cubed term, so when I write my final answer, I have 2x cubed plus x squared, and again, if you ever have a 0 down here at the bottom, we don't need to write it. Now we don't need to write it, but just make sure you skip over that term if there's a 0 anywhere. Plus 10x plus 27, and then whatever sign is on this is what sign you put with it, so plus 82 over whatever it was originally divided by, so x minus 3. And so this would be my final answer for that. Any questions on that one? I'm ringing a bell, maybe a little bit. All right, 10. 3x to the fourth plus x cubed minus 4x squared plus 9x minus 3. Oh, I guess I should tell you what it's divided by. Might be useful information. And it's divided by x plus 5. So what's going in my box in top left corner?
Negative 5.
Negative 5.
Is it because it would be like the 0 of the thing you're dividing by?
Basically, yeah. Which will be important to recognize when we get to the other
Really
things.
smart now.
All right, so in order: 3, 1, -4, 9, -3. And when I say also if a term is missing, that also counts the constant term. So if there was no number at the end, there would need to be a 3 there, or your answer is going to be off. And also watch, just in case it's not written in standard form, so it's not written in the right order. So just also verify that. Other random thought of the day, but your tests are graded, so I need to give those back to you. All right, so, and I always like to note that what term this was to begin with. Not as critical here, but as we get farther along with this stuff, it is important to know, because we're going to keep working our way down all the way pretty much until we get down to nothing left. So, so bring down the 3. 3 times -5 is -15. Plus 1 is -14. And as these numbers get bigger, I do already have them, just FYI.
We did them in the examples.
These
or
were,
in the notes.
oh, because y'all didn't read the thing that said stop at a certain point.
I stopped at 28
I
minutes.
did not.
I didn't
told
get
her to
any
stop
of
at
these.
28 minutes.
Whoops.
I told her in Bible. I said stop at 28. She said okay.
Oh, I just said okay then. I didn't hear what she said. I just said okay.
But I already have them multiplied out, so I'm not just doing this math that quick in my head. -14 times -5 is +70. -4 is 66. Times -5 is -330. Plus 9 is -321. Times -5 is 1605. Minus 3 is 1602.
These are some fun numbers there.
Yeah.
By the time I got to like 320 by 5, I just
Stop. Just
like I'm just gonna wait.
Like I was gonna just wait when I got to like the 66, but then it was like, I guess I could keep on going, and somehow I got it right.
So this ends up being 3x cubed minus 14x squared plus 66x minus 321 plus 1602 divided by x plus 5.
So if we had like a 0 in the spot where it would be like the squared term, would we just skip that and then would the next one be squared, or would that be
No.
x?
It still would have been, so this will always be your x cubed, this will always be x squared. So if there's a term missing, that whole value, whatever that x value would have been, is gone completely. And so you just keep going and always working your way down.
It's basically like 0x to the whatever,
Yeah.
which is just.
Which you can write and then just, don't leave a 0 in a problem. But just rewrite it if you do that. All right, 12. X to the 8th
Ooh.
minus 1
Oh.
over x plus 2.
Like it was like ooh big, and then like it's not.
So what number is going in the box?
-2.
-2. And then I've got 1 x to the 8th. So now I need 0x to the 7th, 0x to the 6th, 0x to the 5th, 0x to the 4th, 0x cubed, 0x squared, 0x minus 1.
That's
I'm gonna
beautiful.
mess this up.
How do you manage to do that, Virginia? That's cool.
So bring down the 1. 1 times -2 is -2. -2 times -2 is 4. 4 times -2 is -8. -8 times -2 is 16. 16 times -2 is -32. -32 times 2 is 64. 64 times -2 is -128. -128 times -2 is positive 256. Minus 1 is 255. And no, I didn't already have that one written down. I actually had to think about it.
It was nice and small at first, and now it's so big. And it's,
Was it worked out in the video?
Yeah. The
Oh.
whole thing.
Normally I don't work it out. Normally I just show how to set it up and then I leave
Oh,
it.
wait. No, it wasn't. No, I did that. So I can tell you what the final answer is.
Go for it.
X to the 7th minus 2x to the 6th plus 4x to the 5th minus 8x to the 4th plus 16x cubed minus 32x squared plus 64x minus 128 plus 255 over x plus 2.
So I went from something so nice and easy to misery.
Which took me 2 minutes because I used my calculator the whole time.
It was so simple, right?
I know, but I didn't feel like doing it.
It would have been faster to just use your brain.
She put 4 times 2.
Okay, I didn't do that. Now that's a low blow.
I mean, I actually would believe it if you did.
I started at like, well, because then I forgot what 16 times 2 was, so then I started there.
So it took you 2 minutes to figure out 16 times 2.
No, it took me 5 seconds because I used my calculator.
But then the others took you 2 minutes. And all.
Don't judge. Don't judge.
All right, remainder theorem. So use the remainder theorem to find the remainder when f of x is divided by x minus k. So number 14, f of x is equal to x to the 4th minus 5, k is equal to 1. So the remainder theorem is really nice. Whatever k value they give us, we just plug it in for x. So we would have f of 1 is equal to 1 to the 4th minus 5, which is negative 4, and so the remainder would have been negative 4.
That's simple. For now, anyways.
What did I get? Like k equals 27.
They don't give you k values that big. The biggest k value is negative 3.
Oof.
It could be worse.
18,
I mean, they could.
f of x is equal to x to the 5th minus 2x to the 4th plus 3x squared minus 20x plus 3. K is equal to negative 1.
Oh.
I don't understand why the screen keeps changing colors.
I like how it was on the paper.
Because it just feels like it wants to be a bit moody today.
Yeah, apparently. It's like mood rings. It's like, oh, I got cold. And then it's like, oh, I got warm again. I'm angry.
I'm hopeful. Question mark.
I'm hungry. That's the problem.
Yeah.
All right.
I know the feeling.
So negative 1 to the 5th minus 2 times negative 1 to the 4th plus 3 times negative 1 squared minus 20 times negative 1 plus 3. So this ends up being negative 1 minus 2 plus 3 plus 20 Am I missing something?
I don't.
Plus 3. Thank you. I, for some reason, was thinking that's what was getting plugged in, and I was, like, losing it. I was like, what is happening? I was like, something's missing because this isn't the right answer. So then negative 3, positive 3 cancel, so I'm left with 23.
Yay.
I was like, the answer's supposed to be 23, and it's coming out as 20. Like, there's a problem.
I mean, you could just throw a 3 in there and pretend that nothing happened.
Yeah, exactly.
All right, next ones. Use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. So 20 is x minus 3 is the first polynomial. Then the next one is x cubed minus x squared minus x minus 15. So in this, determining if it is a factor or not, right now we have x minus 3. So we kind of need to imagine that's basically set equal to 0 to get what value we're plugging in, or you just need to know that whatever their sign is here, I need to change it to get my k value, and then we basically work the same way. And so in this case, k would be equal to 3, so it's opposite sign for that. So if it gives it to you as a quote-unquote factor, we have to change the sign. If it gives it to you just as k is whatever, then we just plug it in. So then now f of 3 basically is 3 cubed minus 3 squared minus 3 minus 15. And we want this to be equal to 0 when it's all said and done. So 3 cubed is 27 minus 9 minus 3 minus 15. And so 27 minus 9 minus 3 is, what is that, 15. And then minus 15 is 0. So this one is a factor. And so all it's looking for is yes or no. But it's answering the question of if it's a factor or not. (24) x plus 1, and then we've got, oh boy, 2x to the 10th minus x to the 9th plus x to the 8th plus x to the 7th plus 2x to the 6th minus 3.
Okay.
So with these,
At least they gave us a 1.
if terms are missing, we don't have to do anything because that just means x was 0, basically, or there was a 0 in front, so it's gone, so we don't have to worry about that. So these are not like adding terms or anything. It's only on synthetic that we're adding the terms. So k in this case is what? Yep, -1, so we change the sign. So f of -1 is how I'm thinking about this. So 2 times -1 to the 10th minus, parentheses, -1 to the 9th plus -1 to the 8th plus -1 to the 7th plus 2 times -1 to the 6th minus 3. So this is going to become 2 times 1 is just 2. Now, the reason I specifically said parentheses around is because it's minus parentheses -1, because the -1 raised to the 9th is still -1. But then times the negative that was outside, it's going to become positive. So I'm saying that just so you'd watch your signs. The -1 to the 8th is +1. -1 to the 7th is -1. Then -1 to the 6th is 1, so times 2 is 2. And then minus 3. So that ends up being 2, 3, 4, 3, 5, 2. So that is not equal to 0, so this is not a factor. They're just looking for now. So as long as it's equal to 0, it's a factor. Otherwise, basically, we've just said there's a remainder to the problem. Any questions on those? All right, we only have like 3 or 4 minutes left, so I'm going to stop there. What we'll pick up with tomorrow is basically having a polynomial. It'll tell us the degree, and then it'll tell us what the zeros are, and so we're doing the thing where we basically are working backwards. They're also going to tell us what the leading coefficient is, which means by the time it's all said and done, we have to multiply by 2 across everything to get our final answer for that. So that's where we'll start off tomorrow and then go from there. We should finish the section tomorrow pretty easily, so probably quiz Tuesday. That's what I'm thinking based on that.